let's see if it's working. Should be. Cool. Well, welcome to 10:35 Saturday night. Take on projects like this and you don't get a whole lot of party time. Going to try to continue programming this thing. Last night I was having all kinds of issues because all of the in-process stock that Fusion uses to look at your model and help you determine tool paths was not, I think my second folder there wasn't it wasn't jiving very well. Something I clicked or something I did definitely made it unhappy. So I'll let it recalculate for like 4 hours, and looks like everything's looking much better. So at this point I got, I believe, everything on the deck minus the intake ports done. Hopefully that's what I'll be focusing on tonight. I gotta finish water jackets on the exhaust. Gotta put those smiling exhaust water jackets in. I got most of the water jacket and everything here worked out. I do have an unfortunate collision. I got to order a different tool because the tool doesn't have enough length. And it's wanting to rub the shoulder and the valve cover rail. And then I believe everything up top here is done. Got those reamed. We should be all good there. And then side detail. So I might warm up with some 2.5 axis stuff and finish this stuff up here. Oh, I do need to get a folder from the desktop. Let's see. I think got a picture of the tool list that I work with at my day job somewhere here. There we go. So I'll leave that up, switch to it. Still on one monitor. I think I would have upgraded that by then, or by now. Too darn busy. Might need to address that. I don't know if that's an artifact or not. It's not supposed to be. Oh, we'll have extra thickness on the deck. That is no problem. So, finishing passes. I guess I'll add to that folder. So we got those drilled. My minimum radius here is 100 thou. So I do need 1/8 of an inch unit. So I'm trying to copy what's already in the machine I'm getting the privilege to have access to. So 125. Don't know the holder. So 1/2 inch of flute length. Let me shank rubbing. You can also 2-step it. 3/4 of an inch of stick out. Nope. Enable that. And actually, before I forget, enable that. Okay. Because I got rough. Let's see if we can see adaptive for the roughing. Let's try. Okay, we'll go with that for right now. Cutting feed rate, we can get that to like 80 for adaptive. 60. Plunge feed rate. Shouldn't be plunging, but we'll just leave that there. And I'm actually square to there, so that's good. So no tool orientation, pockets. All the red arrows are the same color as my model on the right side of the contour. Select the depth down to there. I guess I'll keep it stop top. 20th out of leave. 10th out. Below, that's way too much for that. Climb, always. Probably don't want to run that there. Okay. Make sure I have enough flute length. Okay, 3/4 of an inch. Oof, that's gonna be close. 3/4 to there. All right, that'll work. So what's that leave me with? Big section. That corner. Let's see what this looks like. Oh. So what tool number was that? 1215. forgot to see. Let's do that for now. That should work. RPM. It's probably about right. Not plunging. Cool 15. Boom. Select. Ramp a little, so we'll cut it at 20. That contour, that one, and that one. That amount of stick out, I'm gonna crash. Gotta increase that. This because I'm going to end up shank rubbing. I don't have enough flute, so I'm going to go offset this by 375. Don't really care, lead out, don't need a vertical. Horizontal lead out, that's fine. Forgot to click ramp. Rather important. Clearance. Get right down in it. It's a little aggressive. I'm really good at breaking 1/8 inch end mills. Still looks too aggressive. I don't want to like max out my tools. That looks better. Okay. Duplicate. Do that. Heights. That'll be 0. Okay, we'll see what that gets us. Alright, looks like it's going to get that corner pretty good. Getting messages from my buddy that he's at the bar where my dad is apparently playing music. Here I am programming. Wonder if he knows I'm live. Okay. That takes care of that. Can't remember what I programmed these to be in width. 80 thou. I have to load a cutter. I forget I have to do these O-ring grooves too. Hate that. Should be 2 passes with the 16th. That we don't keep in the machine, do we? Nope. All right. Generated. Oh my gosh. Protect, not optional. Protect. Okay, engineered square corner there. How do I want to go about that? See if Pocket will let me do what I need. Tool orientation. Z-axis. That will be X. Alright? No. There we go. Into flat and no. Or should I use a corner? Let's use that. See how smart Fusion is. We got a wall there that we got to respect. Be the bottom. You know, I got to rough the whole pocket out. Cancel. Adaptive clearing. Let's try this. Tool 4. Is it 7? 4. Okay, blah, 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 blah. Orientation. Okay. Machining boundary. Shouldn't really need any. Okay, optimal load, we'll say. Be nice about it, 50 thou. Let's say 0.7, find step down, 0.03. Yes, slot clearing, don't really care. Yes, do machine cavities, stock to leave. So, actually I'm going to be trusting. Leave 15. Let's just gonna slow it down. Tighten this up. Okay. See what that gets. Just thinking about it. Did I tell this the right height? Probably didn't. Nope. Go to there, it's going to try to clean that. You know, that's okay. It knows that that's mostly solid. Let's try that. See how mad it gets if I try to move on while it's generating. These were okay. I did adjust those out. .213 drill. Where are you? There. See it long? Okay, that's fine. Yeah, sure. See if it gets all the depths right with the auto select deal. Then can I go deeper? Nope. Those are right down onto the port. No, do not click that. Whole top, top height. Probably right there. Okay, I don't like that adaptive going into there. That'll get taken up on the next operation much more efficiently. It's just finish facing that. And I don't want it going around on the deck. Okay. Let's see here. See if that works. It's all made to be finished with a 1/2 inch tool. can thank me for that. I'm not looking forward to drilling that. 7.5 inches. Okay. It's not stopping me, so select 25. Oh, good. 2 tool 28s. Nine 40, 41. Okay, I need to go. That one needs to go to tool 42. New tool. Probably need to import more holders here. So let's see. Boom, boom. Really? Okay, cat 40, there's the bottom. Oh. Okay, I'm pretty sure we have that. Copy holder. Paste. Okay. It's generated in the job. Let's see, what did that do? Nothing that I wanted. Okay, now Pick up our tool. I'm gonna run a bit of stick out. Flat end no. So put no 65. Actually, it's 80. I'm gonna bring in my 7. They are 4 fluid. Nope, that's 0.078. Thanks for the double decimal pointing me. Shaft diameter. That's 125. For a length, I think that's about right. Go with that for now. Length blow holder. 1/8 of an inch. We're like 5/8 into it. Oof. Might go 1 inch out. Flute length on those, I think, are like 0.2. So shoulders 0.25. That's more like the form of the tool. Holder. Now I'm gonna find the one I just brought in. Okay. Degrees. I'm not in a hurry for right now. It's fine. And this is a what tool? 40? Nope. Need to make that 43. Geometry. Do that one. And just select them all, and then my arrows are there, there. How did it know? Bottom height. Same depth. Top of the selected contours. Cool. And that will barely clear. Okay. So the contour pass doesn't need checking for me. Height's good. Pardon me. What do we got? What do we got? Don't really need all that. Might be nice to go around one more time, clean it up. Finish an overlap. That can't hurt. Close contour, doesn't matter. Ramp. Lead in and lead out here. Let's see, 700 degrees, like that, like 30 degrees. Just enough to where it bumps off. I don't even have that much room, actually. 2 degrees. Let's try 1. We'll see how it looks. Supposed to be seen. Okay, there we go. That's not going to work in the first place. Print clearance. Get down closer. You know what? We're making that 10th. Okay. That looks about right. Now, why is it not doing the centers? Those are happy. Those are happy. Doing the longer ones, it's not doing the little eyelets. $75. Knots to bug you while you're programming. Okay, so we're going to lie to this thing a little bit. There we go. Cool, 1/2 inch O-ring should fit good there. All right, that's more acceptable. Okay. We will turn on feed optimization. Reduce feed distance, 100,000. Good. Reduce feed. It's not that much. All right. What part of the head are you currently working on right now? So this is the side of the cylinder head, or basically the ends that will be hidden by a cover plate This plate seals up water from the oil area where all your valve springs and rocker arms are. But the end of the cylinder head, this is a pretty integral part of where the water can flow initially into the head. If this is, say, to the back of the engine, your water mainly comes up through this port, that port, and these ports here. And you can see that two of those, like this one here, makes it. I can't remember now. I believe that one, yes, that one intersects with that drilled hole, which we've yet to put in. Another thing I forgot to do. Obviously not that arc. It's going to be that arc. To actually have access to it. It's one of the deals in modeling where I didn't want to go backwards a long ways to remove it. But that, in the next operation, because I can't, because the mill table is here. If I bring I can't orient this table around and achieve that drilled hole. So I'm going to have to wait till I'm holding off the other side. But that hole there will come in and intersect that same hole. So water can come up through the main reliefs in the head gasket, mainly through those two, and fill this chamber, which kind of has the fast track through drilled hole to the initial, like, larger wells of water. And that drilled hole will continue through into the second and third bigger chambers. So you always want water moving up through everything, but you also want to have the ability for the water to get out and move from higher pressure and higher temperature to lower pressure. And so pushing the water through smaller channels can help, especially around the exhausts. Like this is all going to be brutally heat inundated. And so I've made sure to get water, and if not water, then air, and try to isolate as much of the exhaust port heat as possible from the rest of the cylinder head. So that's why the water jackets are actually recessed in here, is if you try to cool this like a big block Chevy or a lot of big block Ford or Pontiacs, they try to get that exhaust port kind of removed from the water system. You can cool this off and it'll just always be hot. The other theory is they'll run a very thin exhaust port and leave a lot of water around it. But typically you want your exhaust port to be as short as possible. So that's kind of my theory here. So I'm like the base of the valve seat, say to the center of this arc, like that's only just over 2 inches. So it's a very short path. You'll be looking at the valve, the back of the valve right here. So it's a very short path out. And I have these tapered down to fit the stock LS headers. This is not optimized for the maximum of what this port can do. And I've allowed a lot of room. If someone indeed wants to go port one of these, they can bring this out. But I believe the radius of this is, not going to tell me the radius of it, but that's supposed to be I believe a 1.6. Yeah. The 3D profiling always adds some weird stuff to it, but that's supposed to be a 1.6 inch circle, so that it fits inside of a 1 7/8 header with a little bit of a reversion trap. So guys, if you want, you can port this stuff out and get a heck of a lot more exhaust port volume out of this thing. But the way it flows, it matches the LS3 flow profile intake to exhaust flow. So hopefully LS3 cams will work quite well with it. But the water flow around your exhaust ports, especially if guys turbocharge these, which I hope they do, having the heat be isolated from the rest of the cylinder head is super important. So if that's the hottest part of the cylinder head besides the combustion chamber, which obviously you want fire there, this is designed to separate, whether by air or by water, that thermal those thermal hot spots from the whole rest of the cylinder head, trying to keep your intake charges cooler. Why does that deselect? Oh, I'm in measure. The more heat you can keep off, which, I mean, we are pretty solid in between this higher velocity part of the port next to the intake, but hopefully you don't have a lot of flow sitting here waiting to transfer heat. You're going to have more combustion chamber heat propagating from there. As the exhaust continues to burn after the exhaust valve's open, that can really torch stuff, and being able to flow the water however you want through this thing, which actually you have any option that you want, is very important. And these end caps, I try to put extra volumes of water there so that if you do steam and it starts surging around, which that happens in any LS that you fry, it's got a lot of places to go, and then also out this out the front here, so it picks up actually from that same transfer tube there, and that water is O-ringed and put out to the very highest point of the cylinder head, basically to the purge point. So that way you can either run a steam line, or if you want to fill this thing up with water in between rounds and you spit a head gasket, you can undo those plugs and get water to spew out the top. If the water's coming out of there, you know that the water's percolated all the way up through these water jackets and is now pushing up to the very top of the head. So that's what I'm working on. At least working on machining it. I'm pretty confident that this thing is going to cool pretty well. One of the nicer things, depending on what setup or whatever someone chooses to do, it's not off the table to push water into either these plates down here or into here. So you're going to push colder water in through the hotter side of things, and I do recommend putting it here because you have a bit of restriction, which helps the heat transfer. And if you have enough water pressure from your water pump, it'll flow out each of these channels here and help cool a very critical spot right next to the combustion chamber. And that's what's the most important about these. But that will push the water out to these main channels. Now these main channels are also interconnected, right? That's way down in there. On the intake side, that gets the water around to the intake side. And if you're running methanol, your intake temperatures drop dramatically. And in naturally aspirated applications especially, if you do run E85 or methanol, you can get frosting and the whole intake tract can actually become very, very cold because that fuel just keeps pulling that latent heat out of the air and its surroundings. So that's less than ideal for having something that you don't want to change size due to thermal expansion and contraction. So I have really nice O-rings to go in this thing, but the least amount of that you can have, the better. So this is made to get the water in on the exhaust side, get it hot, transfer it over, and help balance the temperature in the cylinder head. And where it comes out of these ports here, it'll transfer to the intake plate, and then you can actually pull water out over each cylinder, basically. So your water flow will come in and go to the left and or to the right, and that's where these side pockets are almost more for that higher end cooling system, especially if you dry deck and don't run any water through here and just push it in through the side. Your water flow can go around each cylinder and exit the cylinder head. And if you look at most modern NASCAR engines where they're really thermally balancing them, they're trying to keep almost more like a motorcycle. Each cylinder's got its own cooling water, and that's a better way to do it. Okay, let's see if that toolpath is a spaghetti mess. That's looking better. We got our stock propagated. Okay. You know, I might be able to leave that as an adapter. There's literally nothing critical in there. I might just do that. See, stock to leave, no stock to leave. So you got no other O-ring surfaces or anything in there. That's a pretty mild step over. Still have this pass on the top. I guess that's necessary. Okay. Oh great, regenning again. Okay. See what I do is it maybe that as well. Okay. To the contour. No pocket. No pocket. So our 1/2 inch flat. Bull nose. Don't know if I want that one. Nope. Gooseneck. Nope. Nope. Drills are down there. Okay, maybe I haven't put that tool in. Two inches of flute length, 2.5 stick out, 1/2 inch. Total 11. Okay. Nope, not in there. Flat end mill. 25. That'll go. Pre-fluid, 1/2 inch. Overall length, it's like 4 inches. Flute length 2. I think it's a shorter one. Yes. Cutting data. Sticks out pretty long. Say 1,000. 40 is probably pretty good. 2 degrees, not really ramping. Say 4 or 3. So that's the surface that I want to cut. Stock top. So that cool. Stock to leave. No. Maximum step over. You know what? Maybe I do some stock to leave here. I want like, so I need a contour pass across there. It's all straight. 5, but we want nothing on the axial. Okay, maximum step over. Be conservative with it. I'm not going fast enough for that. Let's try to smooth things out. That should help smooth the surface as well. Helix, 30 degrees, great, whatever. Cool. Strange how it decides some of this stuff. Let's see. That surface, that surface, that surface, and that surface. Okay, guess beggars can't be choosers. Almost 4 minutes to do that. Why? Let's see here. Delete that line first. Project. Anchor that down. Anchor these. Don't need any of the inside details. Okay, offset by didn't like that, did it? Get rid of the offset relation. Delete all this crap. Okay, now we got a close profile. Good. Delete. Like that. What else is residual? Nothing. Okay, I need that line. So how long is this? midpoint, anchor, dimension, so plus 0.6. That way it clears off each side of the head. Offset. .6. No, we'll go a little bit more on that offset. Okay. About 8.5. Mess out of the way. Nope. Different program. 3, 3. Should be about it. Don't need that. Okay. It's like the minimum amount of area for this thing to achieve that wall and face that. Perfect. Don't need the profile selected. Sketch. Other side. Doesn't matter. Okay, project that out. So if we're getting the profile, yep, it's a closed system. Cool. Back to manufacture. Oh. There you go. Glad you woke up. Delete all those. Chain, close chain. Beautiful. Okay. We are cleaning that up. Go. Funny joke. Okay. Cool. You saved so much time by going to less step over and morphed spiral. That's gone. Let's see what we get here. 323. That's better. Back to point. Oh, it's not taking much. Well, 0.3, and then we get a multiple depths finishing passes. Just repeat finishing pass. Should double it, but help smooth it out. Is that going to leave little bumps? That already seems to be at dimension. Why did I screw up here? Okay. Fairly happy with that. Let's duplicate each of these. I'm going to transfer them to the other side. I'll get a machine like that. Yes. Tool orientation. And that face. It's proper. Adaptive. Stay from there. Okay. Should be everything I need to change. Nope. Bottom. Needs to be there. Face needs to be there. Okay. Height should be all based off of that. Cool. All the O-ring details. Delete, delete, delete. Gone, gone, gone. Yeah. Okay. Forgot tool orientation. Well, that's dumb. Forgot the heights. So, boom, boom, boom. There. Now it's not going to try to mill all the way through the cylinder head. Ideal. Oh. That's where I'm losing it. Okay. Edit. Is that a bad thing though? Go back to stock to leave. Gunto there, 0 there. For those to generate. Okay. Still waiting on the adaptive. Try putting this back into offline mode. I don't know why, but sometimes it seems like toolpath generation goes slower when you're connected to the internet with the software versus not. Two adapters, two drills. Okay, contours, those are our O-rings. Let's actually make sure that those look right. Okay. Okay, good. So we didn't finish this one. Tool orientation, no. There. That's correct. This one, let's see. Nice. Dry this time. Top height. It was the same as the final. That actually should be a selection as well. Let's see how many times I can get this wrong. Well, I guess that is okay. Go back to there and 0. No, I want bottom depth. And 5 and 5. Screw it. Adaptive does not need to surface that. Well, it's our corner radius condition. Oh, it's from the shell mill. That'll work. See, what else do we got for drills? Hole making. Okay, 36. Let's see if that can make it. Probably not. Pardon me. So we'll work on this side first. Have to see the origin, to orientation, Z. That's my x-axis, pointing exactly the wrong way. Now it's the right way. There's no way. See, let's run it in there, see if it hits. Holder clearance, 40 thou, shaft clearance. Okay, detected. What happens if I add an inch to this tool? Overall length. So we have 6 with 4 inches. Four-inch makes it. How far through? Really need that far. Crap, that's close. So I would go from there, there, 4.2. That gives me a lot more security. That's not terrible to ask that drill to do that. Okay, now we'll tell it to go to the depth that it needs to go. Selection, got surface, include tip geometry, break would say 50 thou. Okay, just like that's making it. Just go back, make sure drilling with a peck. Let's say 34 thou per peck. How fast is it doing it? 10. Okay, that's getting guaranteed. Well, let's try this at 15. Not terrible. Yeah, with it being that long, we need to drop RPM. $3,000. What's that? $5,000. It's 12 guinea. Money. Yes. Toolpath out of date. Okay, but it did do it. Generate all this stuff, just make it concurrent. Why do we have a remnant of those passes? Geez, 150 saves on this file. We'll do a simulation next. I really can't until it generates the toolpath. This is the really exciting part of it. That would be a face. It's not like it's not thinking. It's not that complicated of features to go do, though. Because I have no patience, of course it's going to keep programming. That's going to be facing like that in the middle. That face. X-axis is the correct way. That's not looking promising for a collision. No. Rid of the retract height. Okay. hate to have to stick that out further. Might have to though. Gauge length exceeds total height of sections. Issues. Have a step to it. Overall length. Not supposed to stick something out that far. Okay. Thought this was America. Let's see here. Adaptives done. Cool, 43. That one can go right in there. Okay, order tool 33, tool 43, back to those, back to those. Let's see what these look like. Okay, smooth transitions to the wall. Gives me enough to clean up on the pocketing pass. That's going to pocket that out sufficiently. Great. Recalc all that. Yes, I'm really sure. Cool. But is that going to still get me into a collision issue? I feel like it is. Yep. It's gonna have to be a custom cutter. How much room do I have in other conditions? Those are all good. It should be fine. And then, let's see. 120. So 150. Let's see, let's edit this tool. Get to buy another custom end mill. Great. Say it's that for now. That'll solve a lot of the reach issues. Let's get a holder. We can go like 1.75. Cool, great. Let's probably move closer to half an inch. Move holder, let's see, shrink fit. Get away with the shorty. Doesn't gain me anything really. Let's see, let's be crazy about this. So 3 inches, 2 inches. I gotta pee. All right. Let's see what we get. I know it's working on. Oh, I wonder if I'm adjusting tools and it's blowing up my stock models elsewhere. That's what did it last time. Okay. How far are we? Finishing passes exhaust. It's on that one. Okay. Anywhere else upstream? That all looks good. Okay. See if it'll let us simulate just with that and not lock completely up. Okay. Not looking terrible on the stock model. So it should get what I did last night, which is a lot of this detail here, getting all the spark plug detail in. What the hell else did I do? I don't think it was anything. The combustion chamber side. Maybe I finished some stuff up on the exhaust. No, I don't think I got that far. I think I just reamed the valve guides and did the spark plug tube holes. Very productive session. Okay, let's see what this looks like. Verification's running. Pause. Continue. Okay, let's see. Contour 46. Okay, that's no big deal. To be expected. Sorry I touched you when you were thinking. I always picked the wrong way. If this gets much worse than this, which it typically runs a little bit better if I'm not streaming, probably going to save this as a stock model and start a whole new file. You can at least export your stock file as a STL and import it in and utilize that as your stock for your next operation. Because this is getting pretty unworkable. Probably for $500 a year, Fusion 360 didn't anticipate people doing this crazy amount of detail on their stuff. It will all be worth it though. If I can get the machine to run this part off for the first and second operation under 24 hours, that will greatly enable me to stick to my initial price, be able to produce these hopefully in line with demand. Partially why I'm doing these, I don't even know if anyone's watching right now. No reason to. Like, you have to be halfway to, like, Hawaii. To, like, catch this during the day. But making sure to do these as much work as I can on the live stream, just so that if people look, people know that one, this isn't any kind of internet fluff stuff, but then two, this is, you know, the real deal. This is a no bull deal. And I hope like what I've shown here on screen, it's like a tenth of what I've sat and endured. It's been one of the biggest projects, if not the biggest project I've ever done. And I hope that's appreciated. I'd do it regardless. have other projects waiting to get tested, some really cool intake stuff. Hope to incorporate some of that into the manifolds for these things. It's more mechanical fuel injection than electronic. But 99 collisions. Ah. Little shank rubbing never hurt anyone. Stock Z. Contour 59. Flat and null. Spark plug tube problems. Cool. Verification is done. Let's let this play. Cool. I got the hiccups. Fantastic. Alright, I'm going to stop touching it. Because I have so little room on the exhaust side, I got to go down to a 1/4-inch cutter. And I'm cutting what I can with the clearance that I have with the shorter one. Excuse me. So that it can feed fairly fast and not burn up a whole lot of time. And then once it completes that, I go and get that longer extended reach there and trying to get it to slot out that top air gap I was kind of talking about before. There's no real good way to do it. And that groove is in there pretty deep. I think that tool is excessively long for what I need it for, but it's what I got to work with. So what I pray is that thing hangs in there. I'm cutting super light. So finish might not come out super stellar there, but hopefully I'll cut it and be close enough. It's not an important feature on the head other than it just needs the material gone. And then this is finishing up really basic kind of ramping in feature, ramping down feature to finish this top sections in between that top slot and the bottom faces. And that way I can get the drill in there and safely start the drill for the exhaust plate that goes on the outside. That should be the last of that tool. Nope, we got one more operation. 1227. Sometimes going a little slower lets it process a little bit better. Okay, just doing those top corners separate. I genuinely feel that this is more of a Fusion 360 issue than it is a computer issue. It's crazy. It's actually using the 3060 pretty good. Roughing tool should come in. I think that does the outside of the exhaust ports. You know, whenever it decides to do it. Try dropping this a little bit more. Cool, it self-crashed. That's always cool. Going to tool 32, 1/4 inch ball and mill. To tool change, it's not that hard. If you're watching this and you're a Fusion 360 or Fusion 360 expert, if this seems unreasonably slow to you, please comment. Do I need more horsepower on the computer side of things? Is this typical of Fusion 360 to just get bogged down on big programs like this? I'd like to know. For my day job, I use a program that costs the company like $20,000, and I've gotten it to crash the stock model programming on it as well, but not nearly this difficult to work with. And usually Fusion's a dream to program on. It's really a good program. I just don't think it's designed to do this scope of work. I'm pretty sure that's not even cutting yet. Come on, go around. Please. Please go around. No, do the recovery file thing instead. I like that. You're right. Oh my God. $12.50. See what happens if we go next operation. Does the stock model adjust up to it? You see the stock thing down here. Okay, that might be how I skip through this thing. Let's see how many drills. Whole bunch of drills. Okay. That's running really slow. There we go. Boy, oh boy, oh boy. Stock is caught up. That's right. Those just do the little bolt clearance deals. Can't remember what. Oh, for side detail. So let's clean up the edges. Right there. Right there. Make sure these drills are starting on all flat material. I'll change the operation around. Looks like it's good. Pocketing. Nope, click the button too many times. Why? Might just be thermally limiting itself. Might have to do an offline video, the simulation on this thing, because it's just really dragging. Trying to do this, leave a nice finish on the walls and the floor. Okay. So now we're rocked over the axis to 100 degrees. Let's see if I'm right. info. Yep, B-axis 100 degrees. 10-degree intake valve. You got 0-degree exhaust. Okay, cleaning up the rocker stanchions. Making room. One of the things you don't want to have happen is leave a bunch of material and let your finishing passes with your finishing end mills. Not that they can't take off a bit of material, but pardon me. The you don't want your finishing passes coming into a bunch of material. Long story short, it winds up deflecting the cutter, and it can really reflect in. If it doesn't break your tool and other problems, it will affect the accuracy of how you're cutting. So I tend to like to use pretty simple means and methods to cut away material. That way your finished passes got plenty of room to do what they need to do. Clean up nicely. See, pocket 16. Is that leaving a rib? A little bit. Okay, rocker stanchion. Bottom. So that was a roughing tool, and I think it come back in with a 3/8. The 1/2-inch tool can't quite make it through this little pass right here. That's a 3/8 tool, right? Yeah. Don't like that little remnant. Cool. So that actually cleans up that pocket. Why do we have a gouge? That's not supposed to be there. So the corner radius end mill, 30 thou. Using a pocket or open pocket routine. So that should come in and clean the rest of the exhaust face up. Okay, 3/4 of an inch end mill. Finisher. File again to the stuff I worked on last night. These don't need to be super accurate, but helically boring with a Haas CNC tends to get you about the best finish and most consistent result. Tool 38. So this is going to get down to the bottom of the spark plug hole and then do some cleanup, and then 39 should be a very equivalent tool to it, but not a corner radius tool, and that will do the square bottom for the spark plug. I'm not using the tapered typical LS plug in this. Anticipate running like NGK flat washers. I think there's a lot more tunability and options out there. Then to save time and a lot of tool path, I love helically boring in. I don't know if what I'm doing here is totally necessary. I might be able to drop that tool path to not start from the top. Milling. Okay, remove the exhaust guide holes. Should switch over to the intakes. One of my reasons of starting the head in this orientation as well is so that I can get in one milling operation, all of the guides, all the seats, everything in. Not that I trust the mill to completely line everything up. Oh, that's a bad one. Got no holder for that tool. Okay, tool 39. I'm going to select the holder. Whoops. Okay, and on to the stuff that we did tonight. Wonder if I need to step and stage this one too. Shouldn't technically need to. Our holder is clearing. Did that stick out? Okay, that should be the 1/8 inch end mill. Still, it's freaking me out for how much that's taken off in the corners there. I don't know if that'll endure that or not. Apologize if this is boring for you. It's boring for me. Okay, let's see what we get here. It's about anything but efficient. It's probably moving pretty scale to that in real life. But I want to make sure that it's not going to gouge or collide. It looks like this one is actually all pretty in the clear. But where I came in with the shell mill here, the shell mill leaves a pretty big corner radius, and that sharp edge down there, I'd like it to be as close to the sharp edge as modeled as possible. That'll help all of this plate here, which as you can see I have bolt holes all the way through. Most of the center lines, like your lines of force, are going to clamp each of these O-rings down pretty well. fastening screws go on the inside. That's why those as well get O-rings. Otherwise, you'd get potential water seepage out those. You don't want that. You want these things to go together and stay together, stay sealed up. Then from this point, should flip over and do the second adaptive. Cool. Probably same thing here. Jump to the next operation. Drill, we know what that looks like on this side. That is getting way, way close. Hopefully this cutter's got a little bit more angle to it. I'm going to have to make sure of that. Can't wait to hear these things crack off though. That's what keeps me going. Yep. You'll have to extend out even further. Yeah, we get the point. Guess I could relieve the valve cover rail there. There we go. Cool. Should rotate to the other side. See if we can see it poke out on the back side here. Haven't determined if I'm going to use yet an even longer drill for that deep 3/8. The passage doesn't need to be 3/8, but just the bigger the drill, the better it deals with stick out. If I'm going to drill to the center, I might still do a post process and use this drilled guide as a kind of a tool control guide rod, and go and get like a 5/16 drill and drill the two centers out. So not that much in area reduction. Maybe I do it with the 3/8, but I do know from where that drill is going under, it is right, it's within a 1/16 of an inch of this radius here. So I would love to be able to machine drive that deeper hole, and I think it's possible. I'm just gonna need probably like aircraft drill or something super long. Something like 7 inches or something, so. See how close this gets to colliding here. Don't have anything, but see if we broke through on the other one. Barely. Did it. Okay. We are getting brutally close to being done with Operation 1. It's probably the most insane thing I've ever programmed in my life. Doing it in my shop with the manual trending table, I get to break a lot of these operations up into smaller pieces and bite them all off kind of in more to easily handle bites. This is a crazy amount of jobs to achieve each of these features and not have the machine take a ton of time to do them. Oh, I guess I'm leaving a post there. That sucks. Can probably fix that way. Having the lead out just takes that off. But a little bit of special tooling. 1/4 inch reduced to 7/8 will get those O-ring grooves. Forgot the ones on the top. I guess I can do that now. I think at that point then all I'll have left is these angled holes for the water, which I'm still trying to figure out a better way than just taking an end mill in and boring in to get a established center to then send a drill in the rest of the way. I would love a better solution than that. I don't know if there's one out there. I know if I use a spot face or a flat drill coming into angled surfaces, it's going to want to walk and move, whereas if I helically describe it and do a contour pass to the bottom, it gives me a pretty good starting point. So I got O-ring grooves, funny angled holes for water jacketing, and then I'll begin to tackle the intake ports, which hopefully will rough pretty easy by this orientation. Should be able to get most everything. I don't think there's any undercut until I get to about there. So if I can get the head out of the way, the machining head out of the way, should be able to rock up about that orientation. If you're looking straight down the Z-axis, come in and get much of the short turn radius done, and we'll be finished in the second operation. I hate splitting the job up like that, but porting this in the negative is just not an option on this machine. So if the intake ports are running up this way, I can't rock the table around far enough, you know, hypothetically speaking, if you leave the tool axis this way. If that's in the mill like this, even with it flipped over, there's just not enough access to get in and port much more than off of 90 degrees. That milling head really likes to get close to the table platter. So if I can, I'm going to go grab that long 1/2 inch car, probably same orientation as these drilled holes, and try to auger out as much as I can with probably an adaptive tool path, and then try to utilize that tool to do some semi-finishing, leaving like 10 or 20 thousandths to finish, just the same way I did the exhaust ports. And then come in with the 8mm ball with the long tapered shank and see how far I can port down into these while that machine orientation will still be like this, and the spindle can easily get to each of those. I hope. But that'll be hopefully for next time. I'm pretty tired, falling asleep, waiting for the software to work. I am pleased that it finally kind of pulled through and gave you guys something of a simulation. Again, apologize for it being boring as hell. If I ran it like this, it would not be so boring, because there'd probably be sparks flying and all kinds of bad stuff with that much tool holder collision. I'm really contemplating putting some relieving marks in. Technically, like that. Let's see. That's not getting into anything. If I relieve that enough, I wouldn't have to get a new key cutter, and I could leave that tool as it is. And again, before I go run this, I'm going to have all of these critical crashes worked out of this thing. You might still see some shank rub, or stock to leave, or rapiding through stock. I don't have much control over that, unfortunately. The adaptive programs just kind of pick what they do, and it could be an artifact with me running the accuracy on the stock model so low to get this thing to even do anything. Hopefully those aren't going to be a big bummer. The machine rapids, I think, as fast as 650 inches a minute, and I'm cutting at like 200 or 240. So if it's eating off, you know, and a tiny amount at 12,000 or 10,000 RPM, I'll probably look past Fusion's warning systems on that thing. But, oh, I did only do one, did I? It's really hard to see that way. Okay, that did, each of these did get 3D. I'm like, I know I did that. But if I can get this to where there's no technical collisions and they're all realistic tools to be built, it'll go on the Haas UMC 1000 and see if I got any other limit switch issues or anything else, which I think Fusion 360 would give me the option on that. So if I do, oh my gosh, scroll up, please. Let's see here, setup, edit, setup. I should be able to move this machine around. Let's see here, part position, post process, stock. I don't know what's in here. You can actually move the machine around. Preview machine. There we go. So if we have the B axis, what is it? At negative 35 degrees right now. That's, oh, that's the limit travels. Okay. So if I have this thing, I think the furthest I have this is at like 120 degrees. Something pretty miserable. And then the X is over here. The Z definitely is letting me know that I can't do that. Let's see how far the Z will go down. So I think this thing would give me a limit switch error. Tool diameter, let's see. So I think this thing would give me limit switch issues. And I think the, let's see, rotate that 180. You know, I'm probably not that extreme on, let's see, 110. See what that gets us for B axis and inclination. So I might not have any limit switch issues, but the only way you know is to go out there and fake your setup and go run graphics on the control, which is pretty handy. It'll let you know if you're over traveling, under traveling. Just for shits and wiggles. Let's see what posting this thing out looks like. UMC 1000, program number. I don't care. Pick a number. And then don't do optional stops. Yes, preload tool. Safe retracts and positioning. Force XY home position on indexing. Yeah, that's not a bad idea. Safe retracts, great, multi-axis. Clamp codes, I can't remember if that's a good thing or bad thing on that machine. Probably do want them because I'm not doing anything live. Built in. Okay, yeah, there's your maximum feed rate right there. Vacuum circular. Smoothing mode. Probably go with automatic. Subroutines, don't need them. Use GO. Radius ROC, I don't want that. See what happens here. See how many lines of code this is. Oh my god. So this is making a text file, converting each of these blue and funny lines and yellow lines to G code, and it's a very simple programming language. Holy crap! Look at that RAM climb. How high do we think we're going here? So what I think it's doing behind the scenes is each of these independent toolpaths, it is stringing them out and emulating each of them and converting all that toolpath centerline, which is just geometric principles that the CAM system helps you develop, into, in this case, .nc or .txt generic NC file. But it's going to compress. I've never posted out a program anywhere near this large on Fusion. I've had some pretty big files, but I've never seen it do this to the RAM. It's probably going to have to compress the RAM. I think 52 gigabytes is crazy. Okay, you can see it. Considering all of these toolpath. Just want to know how many lines of code it is. Less than a gig available. Holy crap. I would not be shocked if this thing crashes right now. That is incredible. Yep, starting to compress it and write it to the disk. Never a great sign. So that's when the RAM takes care of it all. Oh boy. Come on, baby. This is crazy. Oh, screen just blinked. That's not good. Lost mouse. Screen blinking again. I bet we crashed this thing. See what the live feed looks like. Probably like garbage. Weird way to end a stream. Oh. She's fighting, boys. Fighting for its life. Holy crap. Okay, we're not full. This is going poorly. I just want a text file. This is going poorly. I just want a text file. So what's funny is on the live stream, it still shows Fusion all locked up. But that's not what I'm looking at. I got a blank work canvas and at least Task Manager's at least up and going. Video feed seems to be working. So if you're just joining us, this is how to crash your computer 101. I hope it actually doesn't crash and lose my cam data. Of course I didn't save before this. I had no idea that this would flip the computer out this bad. Crazy. Oh, I'm getting some data back on the screen. Cool. Lost my red light go to bed filter. I really want this to recover. I don't want to lose the 4 tool paths I'll lose. Oh boy. That's not very good looking. Is that also coming through on the live screen? Because that's crazy. Try not to get the echo thing going here, but this is bad. We got a total machining time of 13 hours. Okay, view code. Highlighted a student. Okay, cool. Let's see how many line numbers we got here. Oh boy. That is absolutely ridiculous. $2.2 million lines of code. Great. I don't know if this is even showing on OBS. I think it broke it. Holy crap. Let's see here. Well, I apologize if you can't see anything. My background looks like a bunch of shattered green glass with some of my toolpath in it. I don't have the window around. It looks like OBS is partially functioning. Well, I apologize if you can't see anything. My background looks like a bunch of shadow. Well, I'm going to take a picture of this and I'll do a post. We'll probably end off the stream right about there. 2.2 million lines of code and broken software later. Well, you all have a good rest of your night. or morning, or whatever the hell it is. If OBS doesn't want to work, because this doesn't seem to want to work either, I don't know how to shut this down. Okay, there. Good night, all.